Here's our parallel circuit example. I have three resistors set up, 6 ohms, 6 ohms, and 3 ohms to a 9-volt battery, and clearly you can see there are multiple paths. Good news is the rules still work, and we can still use Ohm's law. It's just going to be a little bit different with total resistance, because remember, total resistance when you add more in parallel goes down. Now, with showing your work, great job last time, guys. Some of you, though, I think you just kind of shortcutted or maybe didn't show me all the details and it kind of messed things up. So try to just copy exactly what I do on this video and you'll get an easy 5 points on this assignment, okay? So first thing I'm going to do is total resistance, but remember in parallel circuits, it's the inverse equation. It's not the sum of them. So 1 over 6 ohms plus 1 over 6 ohms plus 1 over 3. Lowest common denominator is necessary when adding fractions if they don't have the same denominator. So the lowest common denominator is 6. So I have to multiply this top and bottom by 2, which is the same thing as multiplying it by 1, so that's okay to do. And this then becomes 2 over 6 ohms. So we're going to just replace that with 2 over 6. And then if I add them up, sorry, I'm a little cut off on the end there. There you go. If I add them up, I'm going to add the top 4, and the denominator actually stays the same. You don't add those up. But remember, this is not total resistance. You have to flip it because it's equal to 1 over RT. So total resistance is equal to 6 over 4, which simplifies to 3/2, or 1.5. All right? So that's probably the hardest thing with this problem is, honestly, just getting the total resistance. Once I have that, then I can do Ohm's law for the total current because I have the total voltage and the total resistance. Again, show your work for this. Sorry if I didn't show it last time to just try to speed up the video. I'm going to show it this time just because I did notice it was missing from some of your work. So I've got Ohm's law, V equals I times R. 9 volts is the total. Trying to find the total current. Yep, that equals times 3/2. All right. Divide the 3/2 to the other side. Dividing by a fraction is the same thing as multiplying by the reciprocal. So I multiply by 2, get 18, and then divide by 3, and I get 6. So the total current is 6 amps. All right, now just a thought real quick in terms of current. This is not a series circuit, so the current's not going to be the same everywhere. Right here is what we call a junction. So the 6 amps is going to come in, but then it's going to split. And here's another junction where it'll split again. The idea is if we do this right, the junction rule says these 3 splits of individual paths, they should all add up to the total we started with. So we definitely don't want to say that these are 6 because that would not be conservation of charge. So I guess we're kind of stuck then because if I look at my Ohm's law setup for each of these, I only know one thing. So how do I do this? Well, the loop rule about voltage is going to be a big help right now. So the loop rule, if I draw it, it is literal. If I draw a loop and go on the first loop here, I only go across resistor 1. So again, like water going down the mountain, if I only pass one resistor, it's got to be the same voltage that it started with at the top. So it's going to drop a total of 9 volts. It's okay if you don't put the negative, I'm fine with that. But now once I've done that, I can clearly solve for the current one. I could draw a loop, which I won't do it on mine to make it cluttered, but I could draw a loop around the middle path. And again, resistor 2 would be the only resistor I cross, so that would be a drop of 9 volts as well. And the last one, of course, would then be 9 volts as well. I know this idea is really weird. You guys see this and you want to add these up. But again, think of it as here's the top of the mountain, and it's taking 3 separate ways down the mountain because it only crosses one resistor on each path. All right. Now that I have those, I can set up Ohm's law again, but this time I'm going to do it for the individual resistors. So let's do resistor 1 right here. I've got 9 volts equals current 1 times 6 ohms. So current 1, when I divide these, this one's a little easier, is 1.5 amps. 2, even though it's the same, again, I want to see your work thoroughly for the 5 points. So it's going to be 9 volts equals current 2 times 6 ohms. Current 2 is 1.5 amps.
So same thing, which kind of makes sense. They each have the same resistance with the same voltage. They should get the same amount of current. But resistor 3, if you think about it, this has less resistance. So conceptually, then it would make sense if it's less resistance, this will probably take more of the charge flow, more of the current. So I'm hoping I get a number bigger than 1.5. So 9 volts equals current 3 times 3 ohms. And current 3 is then 9 divided by 3, 3 amps. So that agrees with my conceptual understanding. Last thing then, some of you guys might look at this and say, well, I'm done. I did the voltage, current, and resistance for the battery and each individual resistor, which I agree. But what I love about these questions is that there's one rule or math equation that we didn't use. We did total resistance. We did Ohm's law for every single one, total and the individuals. But I didn't really solve for the junction rule. I just talked about it. So junction rule is about currents. And if I look at these individual currents, the idea with the junction rule is that the individual should add up to the total. So if I see 1.5 plus 1.5 plus 1, plus 3, and I get 6, that lets me know I got 100% on the problem. All right. Again, hopefully you're watching the video to the end. I ask you guys to then sign off on this, give you my crummy signature, and submit it into Canvas, and you guys will be all good. Easy 5 points. All right. Good luck, guys.